Thank you for the introduction, Dr. Amright. Again, my name is Xing. I recently completed my PhD at Virginia Tech. So today I will talk about part of my PhD research, which is a fungicide study. I think thanks for the previous presenter, like Wendy, she already like explained this disease system further. I will explain a little bit briefly. So stemroid caused by rolfsii. It's a sorbonne fungal pathogen. Picture on the right just show the white mycelium of this pathogen colonized on the crown of the plant tissue in the field. So that's why it's also known as white mold. So this disease is favored by warm and wet weather. The yield loss is typically less than 25%, but it can be up to 80% under favorable conditions. This picture shows the peanut infected with rolfsii barely have any pod left during harvest. So how to manage this disease? Let's first look at the classic disease triangle. We need to have a susceptible host, virulent pathogen, conducive environment, then there will be disease. We can also develop the management practices based on this disease triangle. So efforts have been made to develop the varieties with increased tolerance to this disease, and the culture practices such as crop rotation and the deploying can reduce the initial inoculum, thus reduce the disease. However, the grower mainly rely on the application of fungicide during the growing season for the control. So the efficacy of chemical control can be affected by several factors. First one is the fungicidal activity of those products. What I mean is like how active are those fungicides can inhibit the pathogen growth. Second one is the residual activity, which means how long those fungicides can stay effective after being applied. Lastly is the systemicity. That means how well can those fungicides move or translocate within the plant. This is very important for the control of sorbonne disease like stem rot. It's because you can see picture on the right, the infection of rolfsii are inside the canopy. So how does those foliar plant fungicide translocate into this infection site? That's an interesting question to answer. So in the past years, several new products have been labeled against the stem rot, and we have tested in our field efficacy trials, but we want to learn more about their chemistry. Thus, this study is designed to compare the inhibition of rolfsii by standard and newly registered products through a lab bioassay. Basically, we treated the plants in the field and we brought them to a lab for the bioassay. And we hypothesized that the fungicide with different modes of action will vary in their performance and activities against the rolfsii. Here is a list of the fungicides we have been tested. Mainly, it included 3 standard products which are registered before 2015. And we also include 3 new products which are registered in the past 2 years. In Pontot, Aprovia is not labeled for peanut, but we include this because its active ingredients in the developer is one of the AI in the standard latest product. So we want to compare these 2 AI together and individually. So this fungicide are mainly from 3 groups based on their modes of action. And so the group 3, BMI, and the group 7, SDHI, and the group 11 is QI. So in our field trials, we use a randomized computer design. We have 4 replications for fungicide treatment. We included 5 sampling date covering from 1 to 5 weeks after the fungicide application. So we included 3 plants per plot on each sampling date. That gave us a total of 960 plants in this experiment. We tested 4 tissues, which included 2 leaf tissues and 2 stem tissues. I will explain them further in the results section. Here is how we did the bioassay. This is the 3 plants from 1 plot. This is the 4 plant tissues from 1 plant. And we use the rolfsii grown on the PD agar, inoculated on each tissue. And then we measure the lesion list 2 days after the pathogen inoculation. We further calculated percent inhibition, comparing the stem rot treatment with the control. We use this equation, and we use the mixed model in JUMP for the status analysis. We include sampling date, fungicide, and their interaction as the fixed factors. Because this experiment was repeated in 2 locations, so we include the field and block next into the field as random factors. Moving on to the result, let's first look at how the lesion of the control developed for the 5 sampling date. So basically, we found there is about 15 to 20 milliliter of lesion developed on the 2 leaf tissues and the upper stem tissues. However, only about 7 milliliter of lesion developed on the crown tissue for the 5 sampling dates. So this might be a problem, and which I will explain further. And then we analyze the percentage inhibition of all the fungicide together. We did this because we didn't find any significant interaction between the fungicide and sampling date for 3 out of 4 tissue types. So we analyze the main factors first. Here is we basically found we have more inhibition on the label leaf, followed by the new leaf and upper stem, while there are little inhibition on the crown section. And we also found there is a sharp decrease of the inhibition 2 weeks after fungicide application, which indicate the decrease of fungicide efficacy. Moving on to the percentage inhibition for each tissue type, the label leaf is the second youngest mature leaf before the fungicide being applied. So that means it's already present when the fungicide being applied, and the inhibition on the label leaf can indicate the fungicide activity of each fungicide. So here is how this bar graph formatted. The axis is fungicide with the abbreviations, and the different bars with different colors are based on their fungicide mode direction groups, while the Y again is a percentage inhibition. So there's about 40 to about 40% inhibition for most of the chemicals, but if you look further, the azithromycin and the imperfluozam didn't perform as well as the Lexan and flutrifol, which is a new product for stem rod. For the upper stem, which is the 2 internode long stem section right immediately after the label leaf, so the inhibition of upper stem indicate potential downward or basipetal movement of those chemicals. So we found that most of the chemicals have about 10 to 20% inhibition across all of 5 weeks, but benzoyl and imperfluozam didn't perform as well as azithromycin. Interestingly, both these 2 chemicals are from the group 7, which is a SDHI fungicide. Moving on to the crown section. So interestingly, actually in the field, the crown section is a plant tissue that first got typically got infection with rolfsii in the field. But in our study, we found that there is a really little inhibition of rolfsii on this tissue for all the fungicides were being tested. As mentioned earlier, because we also found very little lesion developed on the control, that may explain in part why there is little inhibition on this crown section. While for the new leaf, this is the youngest mature leaf on each evaluation date. So we assume that it's not present when the fungicide is being applied. So inhibition on this new leaf can indicate potential upward or acropetal movement of those chemicals. So we found most of the chemicals can provide 20 to 40% of inhibition at week 1 of after fungicide being applied. And we analyze this like bi-weekly is because there is an interaction between fungicide and application and sampling date for this new leaf tissue. And the fungicide difference is only significant at week 1, not for the rest. So, and we found that the methylated trifluconazole didn't perform as well as most of the other chemicals. To summarize this study, we found all the fully applied fungicides provide inhibition of rolfsii for up to 2 weeks, and their efficacy decreased afterwards. It agrees with the current extension recommendation that if there is high disease pressure, those fungicides should be applied every 2 weeks. Secondly, those chemicals are also labeled for foliar disease control, such as leaf spot. So the acropetal protection of the new green leaf is beneficial for the foliar disease control use these chemicals. Lastly, the limited basipetal or downward movement of this fungicide highlights that we need to use the application method that can have the maximum coverage so that to achieve the better efficacy for the pathogen control. For future directions, we can use similar approaches on other soil-borne diseases, such as Sclerotinia minor, which causes the Sclerotinia blight. It's another important disease in the Virginia and the Carolina region. And secondly, we can also examine the impact of different fungicide application methods on the inhibition of rolfsii on the different plant tissues. With that, I will thank the findings from Virginia Peanut Board and the Virginia Agricultural Council. And I would like to thank all the people listed for their support on this project. With that, I would be happy to take any other questions. Thank you.
Thank you, Xing. Very nice presentation. And we got plenty of time for questions. Xing, one question I've got is that historically, I've looked at stem rot as being less important than Sclerotinia blight or Cylindrocladium black rot. There we are. What is it now? How important is stem rot versus those two diseases? And you also mentioned that you could move forward and look at other soil-borne diseases. Do you have data, or have you collected results on this for Sclerotinia or for CBR?
So that's a good question, and thank you for the question. And we did look at other disease presence in the Virginia region. So there did have an increase of stem rot in Virginia region, and also especially in the last year, I think the weather is more favorable for the Sclerotinia blight. So we have very high disease pressure from the Sclerotinia blight, but we didn't see much of the CBR.
Okay, times have changed for sure. Speaking of CBR, here's a question from Dr. Tim Brenneman, and he says, did you verify that your S. rolfsii isolate was sensitive to all the fungicide tested? Let me read that again. Did you verify that your S. rolfsii isolate was sensitive to all the fungicides that you tested?
So I think if I understand correctly, we did some sensitivity experiment bioassay to test the different fungicide. Actually, I didn't include in my study, but we did have tested the label leaf, because it's already, the label leaf already present during the fungicide being applied. So we assume that we can use this the performance on this label leaf to test their sensitivity.
Okay, thank you. And Dr. Charles Chen has a question. It's a great talk. Xing, is there any interaction with peanut genotype?
That's a good question. So in our study, we only included one Virginia type peanut, which is Sullivan, one of the most popular variety in Virginia region. I didn't test on other peanut varieties, but it would be great in the future experiment to include different peanut varieties in this test. Thank you.
Okay. Thank you, Xing. Any other questions for Xing? All right. Well, with that, that concludes our Joe Sugg Award competition.